Hello all and welcome to the project Customer Segmentation using Machine Learning. So now during the course of this project we will learn about how we can perform segmentation operations using machine learning. So now basically as you have heard by the name customer segmentation, that means to segment or to make groups. So in this project we'll be doing that with the help of a dataset. So now what is a customer segmentation? Basically, the segmentation term you have heard is segmentation is to separate or to make a group. So customer segmentation is the process in which you divide your customers up based on your common characteristics. Now customer segmentation is based on a particular domain like a marketing domain. In marketing, market segmentation is the process of dividing a broad consumer or business market, normally consisting of existing and potential customers, into subgroup of consumers based on some type of shared characteristics. So as you have heard, based on this, the customer segmentation or a market segmentation is to basically divide a broad number of customers into different groups such as demographics or behaviors, so you can market to those customers more effectively. Now suppose I am building a product based company and I have different customers. So now I have a generated review system for it. So now I have different reviews. So what I'll do, I can basically segment these customers. I can basically segment these reviews in order to get okay what kind of category these groups people fall in, and how can I treat them with the particular needs. So that will help me in my business growth. So this that is all about customer segmentation. So now also there are different customer segmentation applications, like there are different domains where you can use this, that are demographic segmentation, geographic, technographic, behavioral. Basically geographic segmentation is to behind or divide it on the basis of the geography or the area. Technographic segmentation is basically dividing it on the base of technology, like some of the people of my application are Android users or some of them are iOS users. They may have different complaints, they may have different queries, so I can divide it on the basis of that. Behavioral segmentations, like what kind of things people like, what kind of similar improvements they would like, so that would come under all behavioral segmentation. Or similarly, these are different classes of segmentations. So now what is a problem statement? So we have a small data set. Now this is a very introductory project on segmentation. So with the help of this knowledge you can perform any big segmentation project on your own, or you'll have no problem understanding all those projects. So now we have a data set which has certain parameters, as always these independent variables, and based on those parameters some clusters are assigned to them. Basically earlier only the structures are assigned to them, so basically that becomes our test data also. So we'll see how we can assign those clusters. We'll try to do some analysis on the same, like we'll try to draw some graphs, we'll try to find out different relations based on those. So that will be all we'll be doing in this project. So now finally let's move on to the timeline. Okay, what is the timeline? So first importing libraries, data sets. Then the next we'll be doing some data analysis, data pre-processing parts. Then finally we'll be moving to our segmentation model. We'll be developing our model, developing clusters, then checking our results. So all of these things. So let's begin. Hello all and welcome to the notebook section of this project. So now in this section we'll be performing, or we'll be doing some different techniques in the segmentation approach. So now as I have discussed earlier, the basic idea behind this, like in marketing, market segmentation is the process of dividing a broad consumer or business market, normally consisting of existing and potential customer, into subgroups. So basically to increase our business needs, we are dividing our customers into different subgroups in order to understand them better. We'll be using machine learning to perform customer segmentation. That is our main goal. So now timeline, I've already told: libraries, importation, data sets, data analysis, pre-processing, then model building. So now the very first thing is importing libraries. So these are the different libraries. The one is the NumPy, Pandas, Matplotlib, and Seaborn. The NumPy and Pandas library are basically used for data analysis and pre-processing, for visualization purpose we use matplotlib and cban. And then these are all the different libraries and the different scores which I'll be using, like train test split to basically split the data, logistic regression to basically perform the segmentation, decision tree, classify. These are all different models. I hope you are familiar with the logistic regression or the decision tree classifier, random forest classifier, Gaussian, k nearest neighbor, SVC. And then we have different scoring parameters like the accuracy score and the classification report, confusion matrix. Then finally we have the label encoder, cross validation score. Now the label encoder is basically to encode our data, to encode our variables like in the form of different numbers. We have different segments, so that will encode our variable in different numbers. So now these are all the libraries, and the data set which we have right here is this data set. And I'll just restart my kernel once. Now let's go. Okay, so now let's see our data set. What is our data set? So now this is our data set. Okay, so now this has ID, gender, Eve, ever married, age, graduated, profession, work experience, pending score, family size, variable, and segmentation. So now based on the data set, this is some kind of a segmentation project based on the spending score of a person. Like what is the spending score, how that person spends his money based on its profession, based on a work experience, and on based on that we have four categories, I think A, B, C, and D. So on that this segmentation is done. And we have some independent variables like the gender. If the person is married, obviously it will directly say defend its spending score. Like if the if this ever married is low, and the spending score will be low because it will have less expenditures. As the same goes to age, and the graduated will directly affect the profession. Like the graduation is yes, then it would have a good profession, rather than if the person is not graduated, it will have a less work and less known education. So all of those things. So this is our data set, and these are the different libraries. So now in the next section we'll be performing some data analysis, like drawing charts, spending out some different details on our data. Then we'll be performing the clustering. So let's move into the next section. Hello all, and welcome to the next section of our project. So now in the previous section we have seen that what customer segmentation is, and we have seen our data set, imported libraries. So as we seen that the data set has these certain parameters like the ID, gender, if the person is ever married or not, what is the age of the person, if the person is graduated, if what is the profession, work experience, and finally the spending score, family size. Okay, so this all will result into a particular cluster of to a cluster of our basically the data points, right? So moving on, the first thing is that some data analysis. So I'll just right here we'll be doing some data analysis. So the very first thing which we can do is we can check. I'll be writing the some code with you in front of you also, so that you can get an idea of how things are done. And the very first thing is we'll be checking about the different types of data types. Okay, so I'll just write df dot in. Why df? Because I have written my stored my name as df. Okay, df dot info. So this will give me all the data types like the gender and the ever married, age, graduated, working profession. Now if I want to see that how many different segmentations, or basically let us first see a statistical analysis. So we'll just write ds dot describe. And as you can see, there are 10 columns, but there are only 4 columns. Okay, why? Because it is only showing me the things which can be applied, or which can be applied statistically. Okay, it is not showing me categorical variables. If let us see if I can write something. Okay, let let us see that what are the different segmentations we have. Okay, so what we'll write here, what we'll write, df dot segmentation dot value counts. Okay, so now there are a total four categories like section A, B, C, and D, and like think that all of are evenly distributed, like all of the data points are present in that particular domains. So now moving on, let us store in a list called, let us store our things in a list called let us say df dot columns. So these are lists. Let us store this in a list calls, and then I'll say col. So this is a list. In that we have different columns, like these are the different columns: ID, gender, ever married, and all of these things. Okay, the very another thing we can do is we can check for null values if our data is having null values. So df dot is null. Okay, I'll just write some. Okay, yes, so we have some of the null values. So what we can do is we can either drop them or we can change them. So as you can see, if we'll just see the shape of our data, df dot shape, we have around 8,000 values. So this is a pretty small number except the work experience part. So we can drop all of these things, I think. So we can drop the null values, or you can just replace them with a most a random value or a median or any of those things. You can replace it also, but in my case I'm dropping it just. Okay, so I'll just say df is equals to df dot drop NA. Now if I just see my null values, so okay, I have dropped all my null values in order to make things simpler. So now we'll just now plot some of the figures in which we'll be saying that okay, for we'll say we have different parameters like age, work experience, and family size. For that I'll plot a distribution plot. So this is a distribution part. What I have done here is I have written a list for X in age, work experience, and family size. This is the age and the work experience, the family size. Then I'll say n plus 1. I'm basically returning a for loop. And then I'm saying plot a distribution plot of this with the bins 20. Okay, I'm just adjusting that it's with for this line. Okay, I'm this giving this command, and then I'm saying plot dot show. So this is the distribution plot for our distribution of age. You can see that most of our customers are in the between the age of 20 to 60. Okay, majority rise routine, let's say 30 to 60, like 30 years age. And work experience, the maximum work experience is around of 0 to 1 or 2 years, I'll say. Then family size, the most of the family size belongs to 1 and majority is 2, and then we can have the second majority to 1 to 4, I think. Okay, that is a basic distribution of our family size. Then what I'll do, then I'll just try to group my segmentation based on different parameters. Like we have different segmentation A, B, C, and D. We will try to group them based on different parameters. Let's see the age, like the A segment age is like this, and the mix. I have done the mean of all of this. Okay, the mean age for the A segmented people is 44, for B is 48, C is 49, C is 32, and work experience is around the same, the family size is around the same also. So now in the next thing what I'll do, I'll just plot a graph of all of these. Okay, I've got a bar graph. That's the same thing I've done here, nothing extra I've done. I just written plot that kind bar. So it will just plot me that result, like the A, B, and C, or the maximum number of people are in the age section Okay, so age are 40 to between 50 people. Okay, the minimum median age is 44, and only the D, the mean is 32. That's why it is less. Same for the work experience and family size. So now I'll just group them on the base of gender also. How many people on the base of gender have the like what is the male gender age and female gender is like both are the same family 43 and work experience and families are also the same. We'll just plot a bar graph for the same. So as you can see, this is the same bar graph. This bar h, that means bar h, bar horizontal, that similar this bar h. If I'll just do it to bar, so this is my bar graph. So female and male vision work experience and those. Now I'll just group it on the basis of the profession. Okay, what is the profession and the gender? So the profession is like these are the different profession. It is given in my data set. I have a column called profession. Okay, I have a column called profession. So what I have done, I have grouped it in the base of profession and how in that profession how many males and females are there. This is a very single thing. I've just written the group by command. We'll just count it. We are getting the counts. Okay, now I'll just do the same for the spendings curve. I'll just do the same for the spending score. Like how many females have what is the spending score for males and what is the spending score of female. I'll just plot the same thing for it. Okay, so now this is the same thing plotted here. Okay, now if you want to see this also, you can also like plot this also. We'll just copy it and we'll just say dot plot kind equals to bar. Okay, so these base it is a there are many number of things, that's why it has become a complicated. Otherwise there are less, only the male and female. So bar graph is here: male low, male high, male average. Like the male, the average spending score, this count is this. The high, as you can see, the low spending score coil in both male and female is high. Obviously it will be high. So now what we'll do, we'll just plot our regression plot. Okay, we'll just plot a regression plot. This plot a segregation plot. So this in this what I have done is I have three continuous variables. So I have just plotted the how the kind of pair plot only. I just plotted it like a regression line, like how the data is distributed. If the data is normally distributed or how it is uniformly distributed or not. Instead of this, if I would have written like I'll just write SNS dot pair plot and I'll just pass df. So as you can see, this is my the same thing that I have written with the code. Now I am done with the single command called pair plot, and so I have these. Okay, so now as you can see how my things are correlated. Like for my family size and the work experience, as you can see, most of our data is kind of categorical, so we don't have much information from the pair plot, but we have acquired very much information based on this group by functions, like what is the spending score for a male and female, and how is the how are my according to the professions, how many males are there or my females are there, and different graphs according to segmentation. So this is a kind of data analysis of about how you do in a segmentation project. If you want to support the report support or submit a report, what is the distribution, this is how you do it. So now in the next section we'll be doing some data pre-processing part. In that we'll be performing some different activities, then finally we'll be going to building or clustering our different groups. Hello all and welcome to the next section of our project. So now in the previous sections of our segmentation project, we have seen that how we can perform data analysis, or basically what is segmentation, customer segmentation, what are its applications, and how we can perform a simple EDA on a segmentation project. So now in the moving on, we'll be doing some data pre-processing, basically preparing our data to be developed into to the feed into the models. Now before that, we'll just find out a correlation. We'll just find out a correlation for it. Okay, we have already find out the pair plot. We'll just find out a correlation of all the different variables. Okay, this is df. Okay, so these are the different correlations for my numerical values. Okay, for my numerical variables. So id, age, work experience, family size, and these are all of these things. So now we'll be going with two different approaches. So now, as I have told you earlier, that I have basically I have my different segments, like I'll just show you here. We have different segments, like we'll just say df, and we have different segmentation. So we have already present the segment. So in the first approach, what we'll do, we'll just train our data with this, and we'll just try to predict these segmentations with normal models. Then in the next section, what we'll do, we'll just remove this segmentation part, and we'll just try to segment. We'll be try to doing a unsupervised. We'll try to do a unsupervised problem. Okay, we'll try to do a unsupervised problem. In that, we'll remove the segmentation column, and we'll try to segment on the own, like our model will not know, okay, what are the different segmentation. So now moving on with the, I'll just write here moving with supervised approach. Okay, so now this is data pre-processing. For that, first we'll do one hot encoding. I'll just write these are different variables, and then I'll just write pd get dummies. I hope you all know what is one hot encoding. One hot encoding will basically get you the dummy variables for a categorical variables for all of these presents. I'll just convert them into the list of. Okay, so these are the different dummy variables created for my all the categorical variables. Also for the segmentation column, I'll just use the label encoder like A, B, C, and D. It will convert it into 1, 2, 3, and 4. Basically, to basically to feed our model. Okay, so now this is done, and we'll just now plot a kind of bar graph. Okay, these are different segmentations, or the different bar graphs A, B, C, and D. And earlier it has converted into 0, 1, 2, 3. Basically, the A is converted to 0, B is converted to 1, C is converted to 2, and D is converted to 3. So now the very next step is we'll be performing, or we'll be doing the train test split. Okay, so now the next thing which we'll be doing is we'll be using a decision tree to basically train our model. I'll just write dct dot train, and I'll just write x train and y y train. I'll just predict it with d dct dot predict and x train comma y train. Okay, so decision tree has no attribute train. Also, sorry, dct dot fit. It will write fit. What is saying the true value is ambiguous. Okay, dct. Okay, sorry. I have written here. I have to write x test. Okay, so we have our models. Okay, so now I'll just write pred. Now, if I want to see what is the performance of my model, I can just write it with accuracy score. I'll just write score is equals to accuracy score of pred and y test. I'll just write here score, and sorry, accuracy score is not, basically I've written the spelling wrong. I'll just copy paste it here, and then moving down. Okay, I've written this video. So x score is 0.44. As you know, the score is not that good. If I'll go just with Random forest also rf dot fit. I'll just write x train and y train, and I'll just say pred1 is equals to rf dot predict x test. And again I'll just write score here, and I'll just score here, and I'll just do it with pred1. And okay, the score is also 48, a little improvement, but again a very bad score. So these are the different scores. Ideally, so this is not an ideal process of how you do segmentation. I just told you here to show you a supervised algorithm approach. Okay, I have given already the clusters. I'm just predicting it. Okay, that is basically, that has become a basically a classification problem. Okay, that is, this is not a clustering problem. Clustering problem is an unsupervised learning. That means we don't know the results actually. So now in the next thing, what we'll do, we'll just drop this segment column. We'll just drop the segmentation column, and we'll actually try to predict, or we'll try to make different clusters. Then we'll see to it. Okay, what have we done and how good we have done here. Okay, so we'll actually use a method called k-means clustering in the next model, that is a unsupervised learning approach. So let's move forward. Hello all, and welcome to the final section of this project. So now in the previous sections, we have seen all the different scopes of customer segmentation. We have done some data analysis on our data. Basically, we have understood the trends, like what were the different spending scores, or what are the different parameters, like what is the gender in the profession type, what the spending score for different professions, and all of those things, right? So we have done the EDA, then we have understood the supervised approach, like what we do, like we have already present the different segmentations, we have different segments, then how we can proceed with it. What we did is we created some different dummy variables, then all of those things. Then we created, splitted our data, used two algorithms like decision tree and random forest. In that we already scored, or we did the clusters like one, and scores, we did out the scores. So but that was all of the supervised approach, that is not basically a clustering approach, right? So in the next or in this section, we'll see that what is unsupervised approach, or what is the proper way of clustering. So unsupervised. What is unsupervised learning? So basically, unsupervised learning is what you don't basically tell your data what the dependent variable is. Like moving on, predicting a car price. You first train your data with the independent variables and dependent variables, or else in the case above, you trained your data, okay, with these variables, this is the segment, and that way it predicted. It became a classification problem. Okay, but in clustering algorithm, or a clustering or unsupervised algorithm, your computer or your machine does not know what the results are. It will basically work bluntly and the form of your data. So that means where the k-means clustering comes. Okay, what is k-means clustering? K-means clustering is basically basically a unsupervised learning algorithm which works on making different clusters based on the marginal distance of those data points. Now, if you want to see or deep down or go down to the maths of the k-means clustering, you can always go to the documentation, but I'll tell you a brief, like how k-means clustering works. Basically, you have different data points. What it will do, you'll just first assign some clusters. Okay, let us assign 5. We'll assign 5 clusters. For that, it will create different 5 groups, and try to calculate the marginal distance between them. Then on that, it will calculate the mean. Okay, it will what it will do, it will assign, I have started, or I have set k is equals to 5. It will assign 5 different centroids, and with those centroids, it will try to calculate the points or the distance of points near it. Okay, distance of points near it. That way it will have a list, then it will do the mean of it, then it will assign that mean the new centroid, and it will then again it will calculate the distance, the nearest points distance. Again it will assign calculate a mean, and assign a new centroid. It will try to do so unless no new clusters are formed. In that way, the points which are having the highest, or which is the points which are the closest, will come into a cluster. Okay, that is how a k-means clustering algorithm works. So now let us say, or let us see how to do that in code. So with the very first thing, what I am doing is I am assigning a new data set. Okay, I am segmenting using age and family size. Okay, I'm segmenting using age and family size. So I'm just saying, okay, age, this is the new values. I have just written a new data set. I've divided a list in that the different clusters will be there. I'll say algorithm is equals to k-means. And the very important thing is to, I have written the k-means cluster. Okay, I've selected what is the value of k. Now how to select that value of k? So now that is something called elbow method. We'll just see it in that. What we do is we try to use all the different clusters. Let's say I have written here n. Okay, so that means I am using 1 to 11 clusters. I am taking all of those things, and then init k means plus plus, that is the algorithm name, and in iteration is 100, max iteration is 300. Okay, and then I'll just try to algorithm dot fit, and then I'll say inertia dot append. Okay, inertia, what it will do, algorithm, all the different clusters, it will get appended in that list. Okay, for all the different ranges. When I try to run it, first let us see our data set. When I'll try to run it, what I'll do now, I'll just print, or I'll just plot this cluster. Okay, I'll just plot this cluster. Now if you see that this is the for different clusters, these are 11 clusters, we have this inertia. Okay, so as you can see, inertia was very high. The less the inertia, the better. So now as the cluster reaches to 4 or 5, the inertia is becoming stagnant or getting decreased. So we do not want to take the inertia to the last, because it may tend to overfitting of the model. What we'll do, we'll just select the inertia bit, the point middle, let's say the 5. Here the inertia is decreased abruptly and is almost constant for the next few times. So with the optimum number of cluster will be 5, then again we'll write k means n cluster is equals to 5. Then we'll just create another centroids. We'll create another centroids. Okay, centroids to algorithm that cluster centers. Okay, so now what we'll do, we'll just plot these centroids. Okay, we'll just plot these centroids. We'll say plt dot scatter, plot all the different data x and y, and then we also plot the centroids. So it'll just all plot all of these things. So as you can see, all the different data is plotted, and the thing is that on the base of spending, oh sorry, this is not spending score. This is what, this is basically the age and the family size. Okay, the age and the family size. So we have written here, we'll say here, this is the family size, and this is the age. Okay, so this is the family size, this is each for different family size, and it's these different things are there. And this thing, the with different colors, these are different clusters. Okay, and these are the centroids, 1, 2, 3, 4, and 5. That, like, we have selected 5 different things, so 5 different clusters, 5 different centroids are there, and we have different clusters. Okay, so now we have clustered our data into 5 different clusters. I have 5 different centroids. Okay, so this is how a clustering algorithm works. This is how you perform an elbow method. This is how you execute a k-means clustering. So this is a basic idea of how you can perform a segmentation method. Now you can improve this visualization with a lot more, with using different libraries like Plotty and OG. These are different cluster algorithms which can help you to visualize better, and you can take that as an assignment. So this is the whole introduction part. I'll be providing you with the data set, with this data set, or you can take any of the data set for clustering part. Okay, you can take any of the data set, and you can just try to perform this clustering, try to find out what is the optimal number of clusters. First do it with supervised learning. If you have the different segments, then try to compare it. Okay, what is the result with this clustering algorithm and the earlier segment we have. So I hope you enjoyed this project. Thank you.